So today I thought we'd take a look at these XTAR AA batteries. These are rechargeable lithium-ion batteries. They include a DC to DC converter, which allows these to constantly put out 1.5 volts. So XTAR sent these in for us to look at, including this dual chemistry charger. This charger can do AA's or AAA's, nickel metal hydride, as well as the lithium cells. It comes with USB-C cable, the owner's manual, and at the time of this video, this exact kit is on Amazon for around $53. So that includes the 8-slot charger as well as the 8 AA batteries rated at 4,150 milliwatt hours. They call this charger the L8. It has the Type C USB input, 5 volts at 2 amps. Over QC 3.0 is 9 volts at 2 amps. Up to 0.5 amps times the 8 slots, so looking like it must drop below 500 milliamps if it's 8 though. But we'll hook this up with this USB cable in just a minute and check it out. The little battery case that comes with it does separate out, and we have 4 on each side here. XTAR and 4,150 milliwatt hour rated, so that's going to be over 2,500 milliamp hours on the cell, so that's pretty high capacity for a AA. We'll test that out in just a few minutes. First, let's check the voltage really quick here as shipped, and 1.52 volts. The cool thing about that DC to DC converter is it's going to be rock solid throughout and hold that 1.5 volts. I'm going to go ahead and start these charging. So back now, all 8 of these are charging, and you can see the green lights blinking and the red LED on the charger above each respective cell showing that it's charging. And I assume those charger LEDs will stay green and solid when they're fully topped off. We'll look at the pamphlet that came with the cells really quick here. Like they have a lot of different sizes and capacities. Shows us that one lithium battery can be the same as 1,200 dry batteries. That's pretty interesting. Looks like they've been doing this for quite some time. If we take a look at this sheet that comes with the charger here, it says Type C, nickel metal hydride, and lithium ion charger. So we can find the English section here. Here we go. That's a little bit of information on the charger, some of the specs. While it's charging, we'll look at the box that the charger came in here, and on the back we see how it shows 2.7 hours for 8 AA's to be fully charged, 1.5 hours for the AAA's. You can mix charging, so doesn't matter if it's lithium ion or nickel metal hydride. Auto power off, 0 activation, so they'll go down to 0, but this charger will start that process of charging back up. It shows they have the 3-stage charging, TC, CC, and CV, which is trickle charging, constant current, constant voltage. So evidently the way this 3-stage charging works, it trickle charges until it gets above 3 volts, and then it will constant current until it switches over to constant voltage, the very top end of the charging cycle. Shows us portable, better heat dissipation, Hall design. Talks about the ABS and PC materials, and it's a Type C. So back now we are fully charged on all 8 batteries. Green lights are constant. It did not take very long, but I also did not know the charge level they were shipped. Just guessing somewhere in about the middle. Go ahead and take these out. I'm going to put most of these back in the case for now. I will keep 2 out. We're just going to use these 2 to test with. I will say that XTAR sent these in to me, and I received them not long after the bad storm went through this year. And even though deliveries were starting to run, we still did not have power. We had our power out for about a week. Many people in our area were without power much longer than that. And I just wanted to share that I did use these cells kind of like what I call electronic candles. I just put a LED in them, and I just had these little packs like so. I've always kept some of these little battery holders around, and I ordered some more last month. Just very cheap and very handy. Has a built-in switch. You can do it all kind of ways, but I put a JST connector on here for the video to show that you can do a resistor like I've done here. So I have a 200 ohm resistor at the bottom, and I can choose to go across that 200 ohm resistor and give me an extremely long life on this, like a little candle. You can put these in multiple rooms where you never go into a totally dark room. With an extended power outage, that's actually very, very handy to me. You can cut it on and off, or just leave it on the whole time. You'll be surprised how long these things will last. So that's just very low intensity. But if we go straight across this regulated 3 volts output of these cells, the reason I like using these little 3 volt white LEDs is that's going to be really close to 20 milliamps, and that's about the max level you can drive these LEDs at. And if I just take the LED and slide it out, I'll bring my meter over here and show in milliamps mode. I can just use my probes in series here. If I take the LED across the 200 ohm resistor, we'll hit 1.8 milliamps. So you're talking around 2500 milliamp hour, about lasting about 2 months. And then if I just go across to 3 volts straight, we get roughly 18 to 20 milliamps. Believe it or not, you can get almost a week out of this constantly on and staying on. I had these last the whole time my power was out. Just up to the ceiling, just had it glowing, where no room in the whole house was actually dark. Very handy, and this is just one way to use these. Of course, you can use them in all kinds of things, but it was just a blessing to get these in a time where I really needed some battery power and some lights. So I was able to rig these up extremely easy after that bad storm and the power outage that we were in. I've always used things like this lithium battery here, and this is one that I've actually had for years. I just plugged the LED into it, and this battery is starting to get a little bit low, but it has a 1K resistor built in. This is an older lithium battery from like industrial computer backups. So you can find these things surplus. You can find them in recycle bins sometimes, and these things have over a 10-year shelf life, and I have truly had some of these over 20 years that I still use from time to time, because they just last so long. That's not a very bright light. That's a good like night light when the power's out, but it can actually last 3 or 4 months with that 1K resistor, so it's pretty amazing actually. Now I want to take these XTAR batteries and I want to discharge them and see what capacity they show up as. And this might be tricky because these cells probably go to 0 volts output. And one thing I don't like about this capacity tester is, as good as the Opus is, it's not good at giving you the results when something does go open, like a bad connection or it just quits putting out. And I wish it would just pause and hold that last data, but it doesn't do that sometimes. So let's see. It looks like 700 is all it's going to give us for now. 700 milliamps is fine. I just want to drain these down, mainly because I want to at least take one apart and look at the internals. So either way, I'm going to drain these down, and maybe we can see the capacity as well. So we see we holding a solid 1.5 volts. We'll let these go and we'll come back and check on them periodically. So back now, we're over 1500 milliamp hours. It's been over 2 hours, still at 700 milliamp drain, and still rock solid right at 1.5 volts output. That's one thing that's superior about these, is they keep that output until they get to a certain level, and we'll talk about that a little later, but they will go to a 1.1 volt before the end of their discharge cycle. That way it can trigger the battery low indicator on some electronic devices. So that's actually a very handy feature. But if we look at these cells, we see a little bit of a ripple right here. So more than likely the very end here on the positive side is going to have a little DC to DC converter board. So after we get through pulling these down, as low as we can discharge them, we'll just peel this off. And we'll just take a look at one so we can see what's inside. So back now, I did have to step out for something, and when I came back, these were already showing null, so they've already went to 0. So I did not get a capacity on these. I will check these later, and I'll just keep the camera on them so I can be sure that we do capture what they cut off at. And we are showing 0 volts on both batteries. And that is a drawback to these, as they will go to 0. But as mentioned, at close to the end of its discharge cycle, it does drop to 1.1 volts to give some equipment an indicator that the battery's about to go low on you. So let's go ahead and look inside of this and see what the little DC to DC converter looks like. Just going to peel the top heat shrink here. We have an additional wrap. We can pull this off like tape. Awesome. And there we go. Look at that little lithium ion cell. And there's our top little DC to DC converter board up in this little top cap. I'm going to go ahead and pull this strap so we can get a little bit better look. But I'll leave it like this for a little while because I'm going to do some testing with it and put it back together off and on. And then we'll take a look at the board itself. So right now, just for curiosity, we're at 2.9 volts on the lithium cell. So we must have cut off at about 2.7 volts. It's probably bounced back a little. I'm going to take this and stick it back in the charger, and we can do a little bit of testing with it. If I hold the strap on here, it should just charge like normal. And there we go, we're showing red on the charger, and the green LED is blinking on the battery like it's charging. If I let go, it stops, and if I push that back down, it starts again. So if I check the voltage from the charger coming into the cell, it has settled into about 3.2 volts. And then if I release this and start it back, it jumps up to like 4.5 or so volts, like it's trying to test out the cell. And then we'll begin to initiate the charge at about 3.2 volts at this time. So this battery is still below 3 volts internally, and we're just getting what they're calling the trickle charge, the TC charging mode. Yeah, there's our 4 volts trying to test out the cell to see if it can recognize it. And then there we go, it locks in and brings it down to 3.2 volts to start properly charging the cell. Now I want to take a little tab and put back here at the negative, and maybe I can put my meter in series and check the current. I will start off in amps to make sure we're still in trickle mode, because if we're in constant current, it could possibly be about 500 milliamps. And I'll just read that on the amps jack for now, just to make sure. Yeah, we're staying like a little over 4 milliamps, it looks like. So I can go ahead and switch this over to the milliamp jack. Okay, I see what's going on. At first I was wondering why it was pulsing when it should just be trickle charging, but it's the LED going across the battery. So I'm actually seeing all the current up to this DC converter board. So even the flashing LED is showing at 4 milliamps. So we're averaging like 2.5 milliamps. And we can definitely see our LED flash here. So this is just showing that it does trickle charge until it hits that 3 to 3.1 volts on the cell. Then it will go into the constant current. The next thing I want to test here is after charging this battery up for just a few minutes, and I'm at 3.6 volts. So I should be at 1.5 volts. And there we go. And now that we know that, I want to bring over the Fluke 87 again, and I can do microamps with this. So I want to set this battery here with a tab off to the side, and I'm just going to connect up and see if we can read the microamps that it takes from the cell to power up the DC to DC converter. And the lower this number, the better. That's only a little over 15 microamps. That's pretty awesome. Make sure we're still getting our 1.5 volts. Absolutely, there's our 1.5 volts. So just 15 microamps to sustain that output with no load. So I definitely wanted to test that. So how long will this battery be good on the shelf, not in use, or in a device with very, very low use? So let's pull this up. I think it was 15.4. Anyway, it's not real important, just somewhere around 15 microamps. I'm going to convert this to milliamps, so let's divide this by 1000. That's going to give us 0.0154 milliamps. I'm going to store that number and we'll clear. Let's see, now we can take the capacity of 2500 milliamp hours. Let's divide that by our stored 0.0154 milliamps, and that equals 62,337 hours. So if we divide that by 24, wow. So 6,764 days. And we can divide that by 365. Over 18.5 years. So that cell's a beast enough to power that DC to DC converter on top for 18.5 years. And of course the cell internal resistance itself would pull down way before that will be a problem. So that's really good to know. I was not sure how much draw was on the battery cell without taking this apart and actually checking it. That's really impressive. So let's take this little top part apart. Let's get a good look at this board. And there we go. It's not much to it. Pardon the dirty hands. I just got through changing the oil in my truck right before filming this part of the video. So we basically just got one chip, one inductor, one diode, two resistors, and two capacitors. And on this side we're going to have a LED, and this little button is not going to come off. It's probably soldered on, but nothing really to it. Just the LED on this side and a few traces. We'll see if we can get the chip number here. We'll zoom back out. You can see how little this stuff is, and we'll bring over the microscope and get a closer look, and we can see detail a lot better here. The inductor, a coil, is the largest component by far, and then the small chip they're calling U2, which is odd that it's U2. So maybe there's a U1, maybe it's actually under the top. Not 100% sure on that one, but it looks like we have a LC9203, maybe a 3, D8, and that could be a B, but it looks like an 8. But I searched that many different ways and I did come up short. Do not know what this little 6-pin chip is. But there's the LED. And after doing some tests with this, at 3.2 volts on the lithium cell, it goes into the lower voltage output of 1.1 volts. At 2.7 volts, it drops out and the LED flashes for a few seconds. And right at 3.0 volts, the output will come back on at 1.1 volts output. And then at 3.4 volts, it'll come back on to the 1.5 volt output. One more thing I want to check really quick here is the dimensions. So how close are the dimensions compared to regular AA batteries? So the overall length of an Amazon Basics AA is 50.4 millimeters. The XTAR is 50.4 millimeters. Same. Diameter of the XTAR is 14.2. And the Amazon 14.2. So that's identical. Probably going to be a little difference on this part here. Just the body without the tip. 48.7 on the Amazon and 48.9, so 0.2 millimeters there, probably because of the extra protection and the wrap at the top of the XTAR. Very, very close and should be very compatible with just about everything that takes a AA. I'm going to try the discharge test one more time. While testing, I thought it would be interesting to throw the Amazon Basic, the Energizer Ultimate Lithium, and the XTAR there together. So it's 700 milliamps. The Energizer starts out above 1.6 usually, so it's a little higher. Back now, it's been running for a little while, and I'm going to leave the camera on this for the rest of the test to make sure that we do capture the XTAR when it does drop out. And 2 hours and 17 minutes in, the Amazon Basics is done. Drop down to 1.27 volts, 1441 milliamp hours. The Energizer and the XTAR are still going, now approaching 2000 milliamp hours. We're going to fast forward as well as time lapse through some of this, and periodically we'll be checking in and see how this goes. Showing 1.21 volts on the Energizer Ultimate Lithium and about 1.07 on the XTAR. So we know that it's going into that lower output mode to trigger a low battery indicator, and we just see that there in operation, if that's helpful. Approaching 2400 milliamp hours. And I'm going to put the video back on 1x speed here as we approach 2498 milliamp hours, and that is where the XTAR cuts off at, so right at 2500 milliamp hours. Notice that the XTAR does have the flashing green LED for just a few seconds after it cuts off. I really don't know if that's going to be helpful to anyone that's already cut off at that point, but that is a feature they did incorporate into those batteries. The Energizer is still going, but it's still lagging behind in milliamp hours. Its voltage has dropped off further, so it's taking it longer to reach its max capacity. And 2479 is where the Energizer Ultimate Lithium stopped off at 3 hours and 44 minutes. As mentioned, I do want to retest the Amazon Basics and the Energizer Ultimate Lithium as well. So just showing here, I'm going to have a test running each of these also brand new cells out of the pack, just to see if we have some different results. I really didn't like the results on these two in that former test. I absolutely have seen these tests higher in the past. So right after starting, we 1.52 volts on the Amazon Basics and 1.62 on the Energizer. And we'll be right back to check on this and see how this test is progressing. Back now, an hour and 47 minutes in, and for some reason the Amazon Basics is only staying around 580 milliamps, but they're both still set for 700 milliamps and still drawing current. This time we're already down to 1.09 volts on the Amazon Basics, and we're at 1.41 on the Energizer, and so far 1136 milliamp hours on the Amazon and 1242 on the Energizer. So we'll keep coming back periodically and we'll just check on these and see how they're going. So back now, the Amazon Basics is complete. 1.26 volts. That's weird. It was showing lower than that earlier. But yeah, 1.26 volts and 1530. I thought these usually hit the 1600s at a 700 milliamp draw, but maybe I just got a bad batch of these. They are brand new. 2 hours and 32 minutes. And we definitely are done. The Energizer is still going. Over 2,000 milliamp hours. I'm looking for it to hit over 3,000. Typically it does. Right at 3 hours here, and we're still discharging at 700 milliamps. So we'll be back and check on it when it's complete. So back now, after 5 hours and 14 minutes, the Energizer is complete. It pulled down to 1.04 volts and 3613 milliamp hours, so that's probably more like it. I really don't know what happened with the last one. It could be my Opus charger giving trouble. I've had it for a while, but I really had no issues with it. Looks like I'm going to have to buy another capacity tester to be able to verify when I get some bad readings, but it is odd that two different name brands and types did read a good bit differently on these two tests. But I did want to verify a lot of this before I posted this video, because I could tell that testing did not show accurate results. So the Energizer was a larger percentage off by far in error than the Amazon and that former test. So I hope you found that helpful. So before we end the video, I do want to bring over this brand new Finersi internal resistance battery tester. I bought this to use on these cells before I posted the video. I have been wanting one of these for quite some time, and I did end up buying one last month. So we'll take this internal resistance meter that uses these Kelvin probes, so it's got 4 wires to give us a better reading. So we'll try to use both connection points on both ends if we can. I did see 56 milliohms. Briefly, if I can stay on there, it's hard to stay on the tip with both ends of that same probe, but yeah, 56 milliohms. So very good internal resistance reading on the battery. I'll show here with the complete battery with the DC to DC converter board. I don't believe you're going to be able to check internal resistance because you're going through the board and you're not actually going through the cell. Yeah, just to show here, like 1.2 ohms Yeah, 1.4, 1.5. Yeah, it's not going to read through the board like that, so we actually had to take that apart and test the cell internally. And this is going to be a handy meter to have around to check my other cells and other battery packs that I work on quite often. So I hope you found this video helpful. Looking into these XTAR batteries, I really appreciate them offering to send them in. I never would have guessed back in September when they sent them that we'll be going through one of the worst storms at the end of September I'd ever lived through in my lifetime. And having these extra batteries around made it just a little bit easier. So I really appreciate them sending them in. The timing was great. The timing getting the video out probably wasn't great, but sometimes that's how it rolls. So I hope you found the video helpful. If you did, please like, share, and subscribe. So I'm going to have the link for this down in the video description, as well as some other items that I also found helpful on my workbench, including this internal resistance tester if you're interested, the battery holders we talked about earlier, and just a lot of things that I find helpful on my workbench. Any of those links you click on are affiliate links, and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.